friends, welcome to my channel. So today we will be discussing on the most popular pattern in the microservice architecture or the distributed architecture is the Saga pattern. So we'll be discussing on the four of these topics: why we need the Saga pattern, what is the need, what is the Saga pattern actually it is, and what are the different types of Saga patterns, what are the pros and cons of the Saga patterns. Let's go one by one. Why we need a Saga pattern? So in the distributed architecture, there the services are each services has its own database and they are hosted in a different server altogether. Communication between these services happen over the internet or through exchange of messages with the message broker or a Kafka, right? For example, if I'm making a single request like ordering a product, it will involve multiple steps like calling inventory service, calling the inventory service to update the inventory, and then calling the payment service to make the payment for the product what we have ordered for, and updating the shipping, calling the shipping service to update the shipping address and other details of the product which has been ordered. So so all these in there is in this distributed architecture, maintaining data consistency and atomicity is a complex challenge, especially when each service has its own database and operates independently. So how do we guarantee that the payment service succeeds, the inventory is updated, and the shipping process is initiated when maintaining data integrity? And if in case of any failures in this whole process, how do we override and maintain the data consistency between the inventory and the shipping and the payment, the coordination or the how do we manage the coordination among these services? So that is why we need the Saga pattern. Next, what is Saga pattern? What is Saga pattern? So it is kind of a design pattern that helps manage transaction updates across multiple services by breaking them down into a sequence of small transaction updates called Saga steps. Each step represents a unit of work that interact with the single service. Once the step is completed, it triggers the next steps in the sequence. If any steps fails, the saga continues, compensates, updates to undo the changes made by the previous steps, ensuring that the system returns to its initial state. So let's discuss about the different types of saga patterns. So the easiest way to remember these types of saga pattern is one is orchestration pattern and then choreography. So these two are related to the music and dance. You can say orchestration is used in music and choreography is used in dance. So one of the pattern is orchestration pattern, wherein that is responsible for invoking each steps of the saga. It is like a central coordinator. It sends commands to the service involved and wait for the response before proceeding to the next step. If any steps fail, the orchestrator triggers compensating transaction to undo the changes made by the previous step, ensuring data consistency. The orchestration handles retries and failures, making the system more resilient. So one example what we discussed earlier, we'll go through that. So when the client makes the purchase order in the in the shopping, while he is shopping in e-commerce, when a client makes a purchase order, inter- there will be a central coordinator that is the orchestrator, which sets sends the create order to the order service where it updates the order, and then once it returns the success, then it calls the payment service to make the payment. Once that service returns success, then it calls the create shipping services, and once that is successfully done, then it is intimated to the client that your order has been placed. So there will be a center orchestrator which will be acting as a gateway for interacting with the different services and And finally, so all the request is being triggered from the orchestrator. He is the central coordinator or the central command of this pattern, orchestration pattern. Second type of pattern is the choreography, which is nothing but a dance. You can think about if it as a dance. There will be no central coordinator. Instead, each service involved in the saga knows its role and communicates with the other services through events or bus or messages. So there will be a centralized event event hub, or a Kafka kind of thing, which acts as a coordinator, or it's in terms it is like a gateway. I mean, it is like a pathway to interact with the different services. So each services will be listening to a specific set of messages. So they will consume those messages, perform its saga steps, or updates the backend. It updates the do the processing. Each service do the processing based on the messages it receives. So it is event driven because each microservice involved in the saga publishes events and it completes its local transaction. These events trigger the next steps in the saga, creating a chain of events that drive the overall process. So there is no central orchestrator. Instead, each service know what to do based on the events it receives. This makes the system more resilient and scalable. So compensating transactions, in case of any failure in the event, it will trigger the compensating transaction on its own. Like if there is any payment failure, it will send a message back to the it will send a message back to the um, product update for updation and canceling the request. That is how the choreography pattern works. So if we take an example, there will be a centralized event bus. So when the client makes an order, the, the order is created, and then it will send a message to the payment service like create a payment. Order is created, the fourth step, and create payment it will do. And then once the payment received, then it starts shipping. Then payment received, in the sixth step, payment received starts shipping. Then the shipping is done. So your order is completed. Yeah. So what are the pros of the Saga pattern? So data consistency ensures data consistency across multiple services by using series of local transaction and compensating transactions. Resiliency enhance system resilience by handling failures gracefully and allowing partial rollbacks. Supports scalability by enabling services to operate independently and asynchronously. Flexibility offers flexibility in managing distributed transaction without requiring a central coordinator, whereas in case of a choreography saga pattern. So what are the cons of the saga pattern? It is complex. Can be complex to implement, especially in systems with many steps and asynchronous communication. Programming overhead requires significant programming effort to handle compensating transactions and rollback mechanism. Debugging and monitoring in a distributed transaction can be challenging due to decentralized nature of the pattern. Performance may introduce performance overhead due to the need of compensating transaction and event handling. So that's it, guys. Thank you.